Hi.
Can I FaceTime Gabby?
I know the sound. I discovered that why the sound didn't work. It was
I know, it was
at
so
one
weird.
point when I paused it, there is a, I must have clicked there's a place to turn off the
Oh,
sound.
well.
And that's what happened. So
We can FaceTime them.
Yeah, can we just FaceTime Gabby?
all right. So that's how I feel.
Did well.
Okay, I'll hand it back to you. Okay, so Pythagorean theorem and its converse. So somebody mentioned why that this was, this is actually a relatively easy lesson because we've seen it before. We've seen Pythagorean theorem. What's Pythagorean theorem? A squared plus b squared equals c squared. So the key to the Pythagorean theorem is that you have to have a right triangle. Okay, if you don't have a right triangle, the Pythagorean theorem does not apply. So when we first learn about conditional statements or theorems, you have your hypothesis and your conclusion. So first you have to have a right triangle, and then a squared plus b squared has to be equal to c squared. C squared is the measure of the hypotenuse. So how do we know it's the hypotenuse? It's opposite the right angle. Okay, and also you may remember that the hypotenuse is the longest side. Now in terms of a and b, doesn't matter if we switch them around. If it's a b squared plus a squared, it's the same thing. Doesn't matter which one we make a and which one we make b. Not really. It's only c that's the important one. Now notice here, in this whole chapter we'll start getting in the habit of labeling like the capital letters represent the angles, and then the sides directly opposite are lowercase. We've seen this before, but it's important to note that when we, especially when we get into the trigonometry. Okay. So somebody was asking, I don't know who it was, why did they make these mathematicians? How did they know that these were true?
Corey.
How do we know that? Oh, because we proved them, right? There was a theorem.
Poor people.
Oh,
We had
so
a
let's
whole
prove.
class. We had a whole class just dedicated to that.
Okay, well, we're going to go through this quickly.
Miss Casey, what if they just use big words to confuse the public?
That could be.
Corey, that's how I feel like every day.
But Pythagorean theorem was actually named after somebody, named after Pythagoras.
I feel like
Okay,
the creator of math.
okay, discussion.
tortured people.
I went to my friends to very far from school.
So what we're going to do is we're going to look at Pythagorean theorem. We're going to prove it with geometric mean. Okay, so now that we have this idea of geometric mean, we're going to apply it. It actually makes the Pythagorean theorem. This is one of the, there are many different proofs of the Pythagorean theorem out there. This is probably one of the easier ones. So think here, this is your B is a leg, A is the leg, and C is the hypotenuse, right? Okay, so we're going to use the geometric mean for, let's do the two legs. So let's start with A. Okay, so this leg, A, is the geometric mean of the hypotenuse and the segment adjacent to that leg. So we're going to put A here and here. And then C is the hypotenuse, and the segment of the hypotenuse adjacent to that leg is Y. Okay, let's do the same for B. Okay, so this leg, B, is the geometric mean of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So that's going to be C and X.
Oh.
Okay, the only thing I've done is basically set up the geometric mean for the two legs. Right. Okay, let's take the first one, let's just cross multiply. We get A squared equals cy. And over here we get b squared equals cx. Now, if I put these two together, okay, so if I add those two equations together, think about the left side of the equations. I'm going to have a squared plus b squared, right?
CX
Equals cy plus cx. If you switched it around using symmetric property, that's fine. Okay, I'm just adding. So when you did, like in Algebra 1, when you did process of elimination, you added or subtracted equations to solve. Remember, and you would eliminate. You can always add two equations together as long as they're, like you can add a squared and b squared and add these two sides. So what do we notice? Well, on the right side, I can factor out c. Why would I do that? Well, notice I get y plus x is in parentheses. Look back at your picture. What's y plus x? What is it? It's C. Yeah, it's c, right? So if I have c times c, we get c squared.
Wait, but isn't
What's y plus x? We just said that that was equal to c. Look at the picture. Y plus x is equal to c. So if that's equal to c, I have c times c, which is c squared. So we proved.
That's why the cons
So we proved the Pythagorean theorem. Okay. All we did was set up geometric mean twice, cross multiplied, added the two equations, and used substitution, and we got our proof of the Pythagorean theorem. See? That wasn't so bad. I mean, I know we didn't justify all the reasons. We did a proof, but we basically just wrote out the steps to the proof. Let's look at the next page. Okay, so Pythagorean theorem is something that you probably started using in pre-algebra and then also again in algebra. So finding the value of x is basically, you just have to notice where the hypotenuse is. So in this case, which one is the hypotenuse? X. So does it matter which one we make A and B? No, in fact, you don't even have to label it. At this point, I would expect you guys just to plug into the formula. So 20 squared and
I got 18 when you're out of 1806.
question?
That's it.
42.5?
1,806.
1,406.25 is 37 squared.
can I do
Okay, so,
We all do use them.
go ahead. We didn't do the converse yet. Okay, Allie's gonna do the next one.
Are you ready?
You can scroll down.
How do I scroll down?
We didn't do the converse yet. Okay, but
What am I doing?
we're in geometry, which involves the proof part. So that's why we did the proof of the Pythagorean theorem. Some of you may have already done this in middle school, some of you didn't. I just wanted to show you how one quick easy way to prove Pythagorean theorem is using geometric means. So now we're going to apply it. This should be review. This is stuff we've seen before. So, plus we've already done it in class. Now, the converse of the Pythagorean theorem may be new to some of you. So we'll get to that in a minute. Okay, so when it works out nicely, just, square root of 64 is 8. That's your answer. I would like you to put if it doesn't come out to a whole number, then I'd like you to reduce it as radical, but I I know I have in the directions there, you can also round to the 10th place. Yeah, well, let me show you on the next one because we do have fractions involved. So I would prefer you to keep these in fraction form. So let me do this one real quickly and then maybe on another time. Okay, so I have x squared plus 4/7 squared equals 5/7 squared. So x squared. Now when we square a fraction, we square the numerator and denominator. So it becomes 16 over 49 and 25 over 49. So this is why I said leave it in fraction form. We end up with 9 over 49 when we subtract. Okay. Again, the reason I wanted to leave it that way is you'll notice that we have both the squares and the numerator and denominator. So when we take the square root, so some of you again were asking, about reducing radicals. Again, if you're unsure of how to reduce radicals, make sure you come see me. So we get 3 steps. Good? Okay, so the converse. Basically, the converse says if a squared plus b squared equals c squared is true, then it's a right triangle. Just note that that C has to be the longest side. So if that's true, then it has to be a right triangle. If it's close, but not equal, it doesn't count. And it's not going to be a right triangle. Okay, so take a look. Does that make sense? Any questions about that? So when you're comparing how c squared is related to a squared and b squared, so if c squared ends up being less than a squared plus b squared, it's acute. And if c squared is greater than a squared plus b squared, then it's going to be obtuse. Think about that. Does that make sense? So if your hypotenuse squared ends up being smaller than the other two sides, then that means you have less than a 90-degree angle. And if it's c squared is greater than, then it ends up being an obtuse. All right, let's see if triangle PQR is a right triangle. So which side is the largest? Don't always don't assume based on what the picture looks like. Square root of 61, is that the largest side? Yeah, think about 5 is really square root of 25. This is square root of 36. So definitely this is bigger. Did that make sense how I did that? So this would be the hypotenuse, but we're not sure. It can only be the hypotenuse if it's a right triangle. Okay, go ahead and test it. See? Okay, so I have 5 squared, 6 squared, square root of 61 squared. We get 25 plus 36. What do you think? Okay. So once we get the same thing on both sides, we know for sure it's a right triangle. Okay. Somebody want to do this? I'll do it. Yeah, just come on. Those of you. Yeah, it doesn't work. You need the marker.
Okay.
I prefer simplified red.
Whoa. Did this work? Oh, it did work.
What if it's like a fraction?
Yeah. Okay, the reason I want you to really get in the habit of repeating radicals, reduced radicals,
The heck?
there are the sections coming up where you have to leave it as a reduced radical. Not only that, but it's a skill.
Oh, oops. Okay. No, this doesn't work. No, 36 doesn't equal 49.
Oh, I see. I thought she was talking about the pen. No. Okay, thank you. All right, any questions on those? No, because it's still not anything too difficult, anything too challenging yet.
Well, no, in this case, usually what happens is it's pretty easy at the beginning, but then later it just gets harder.
No,
So
it's not,
if
this
we just
lesson
stop
does
right
not get
now.
any harder.
Yeah, it's really easy. It's really easy. I just
Okay.
remember it was brand new. I brand new.
Okay, so Pythagorean triple.
It's really easy.
Pythagorean triple are whole numbers that satisfy this equation. Whole numbers only. So, for example, on the previous page, we did a right triangle. We did one of the first examples we did, ended up, I think, Allie, you did the one where it was 6, 8, and 10. That's an example of a Pythagorean triple because they're whole numbers where a squared plus b squared equals c squared. But then we did one with fractions where it was 4 sevenths, 3 sevenths, and 5 sevenths. It's a right triangle, but it's not necessarily a Pythagorean triple because it's a fraction. They have to be whole numbers. Can we think of any other, can anyone think of any other Pythagorean triples that maybe you've seen? So a 3, 4, 5 triangle is one of the most popular. So we just said 6, 8, 10.
9, 12, 20.
There's a 5, 12, 13 triangle. Now, let me just explain. Any multiple of 3, 4, 5, so like 6, 8, and 10 would be taking these three numbers and multiplying by 2. So like if you took these three numbers and multiplied by 3, like if you had a 9, 12, 15, that would be a right triangle.
How'd you get that? 5, 12, 13.
That's just another example. 5 squared plus 12 squared equals 15 squared. I wanted to show you 3, 4, and 5, and 5, 12, 13 are like the two of the more popular ones that you'll see. Let's check some other ones. How about 8, 15, and 16? Okay, so 8 squared plus 15 squared, does that equal 16 squared? Okay, so Allie, why not?
Because 8 squared is 64, and 15 squared is 225. 16 squared is 256. And when you add 64 to 225, it's not.
Good. So this is no and no. Basically, there's going to be two answers for these. One part is determine whether they can form a right triangle. If the first answer is no, then the second answer is automatically no. Because if it's not even going to form a right triangle, it cannot be a Pythagorean triple. How about the next one? So let's see, square root of 3 over 5 squared. Okay, so let's see first. So it's almost like first we have to see if it's a right triangle. Okay, so just see if it works. If it works, then our first answer is yes. So here we get 3 over 25 plus 6 over 25. Does that equal 9 over 25? So yes. Okay, so we know that it's yes for the first part. However, are they whole numbers? Did we start with whole numbers? No, so it can't be what?
Wait, but what if, like, the not the numbers together? What would become whole numbers?
It all depends on what you start with. It's only what you start with. So for example, like D, right away with D, I don't even have to, just knowing that there's a square root involved, I know that it can't be a Pythagorean triple. It might be a right triangle, but it can't be a Pythagorean
So
triple.
on a test, like, we were to say, are these triples? And then you don't have to do the work. You just
Right, so there would be a section, like we circle yes or no. But, anybody want to do C?
Yeah.
Yolanda?
Can I get the D after?
Aw.
never done this before. I'm really excited.
I did want you to do that. All right, how about B then? Okay, so
Wouldn't I know to be a right triangle because
okay, they don't have to be whole numbers to make a right triangle.
so like
They need to be whole numbers to make a Pythagorean triple. So
yeah.
take a look at C. So C, it could be a Pythagorean triple if the answer to the first one is yes. That makes sense? Okay, so Elad got 2,704 for both sides. So yes, it's a right triangle. Yes, it's a Pythagorean triple because they're all whole numbers. All right, try the next one. Because they were whole numbers and they satisfied the a squared plus b squared equals c squared. Okay, so take a look at the last one. As we square it, don't forget you gotta square the bottom and the top.
Over 7.
Oh, I forgot to do this.
When do we see them? It's a little
Well, no, if I get scared that that's gonna get harder.
Okay.
How do I erase?
There's a bottom button here. This, if you hold that down, it erases.
Ooh. Wait, how do I go back to the other thing?
Hold it down and then hold it.
No, you don't, just, yeah, you just don't, oh, I see. Okay, so we do get 549 on the left and the right side. So our first answer is yes, but it's no because we started with non-whole numbers. Good? That seems like that. Okay. Thank you. No, you get to keep them. Okay, so I'm passing them out as we're going through the notes. It looks like it's working. Okay. So Pythagorean inequalities, I was mentioning earlier about, okay, if it's not a right triangle, then that angle C could be an obtuse angle or it could be an acute angle. So how do we tell? Well, if C squared ends up being less than, then the triangle is going to be an acute triangle. That makes sense? Like the side opposite is going to be smaller than the other two sides.
This makes sense.
Whereas C squared, if it's greater than a squared plus b squared, then it's obtuse.
That makes sense.
So,
Wider.
now what you need to do, just be careful with the order, like the numbers. I have them in order here. But one of these has to be C, the other two are A and B. So I need to compare 9 squared. How does that compare to 3 squared plus 5 squared? So we get 81 here. What do we get? 9? Right, 9 plus 25 is? So since it's greater than, this is? Okay, somebody want to come up and do B? Oh, are you? I can do it. And then, how about you C? And B?
When we're writing it, and you know how you wrote like 9 squared equals 3 squared plus 5
I put question marks
You put
above
like a
it.
different sign there.
You can put whatever sign you want. I just put a little question mark because.
Does anybody have a calculator on them?
Somebody go.
15? 15 squared is 225. 225?
Yeah. 81 and 141.
I got it. I can do this one.
Okay, so just tell me, is it right, obtuse, or acute? Quickly.
Wait.
Guess what?
What?
The answer is right.
Okay, very, oh, here, ruined.
Thank you. Okay.
Okay, so B ends up being right.
And that's a terrible T. Sorry.
You got what? That answer was right. Yeah, I did not.
Oh, I kind of missed. Whatever. Okay. Who wants to do D? Alright, it's here.
Okay, so I'm giving you, as we're finishing up here, I'm handing you my course recommendation for you for next year. This is not set in stone, it's just on paper. So it's just for you to have a conversation with your parents, with me, talking about next year.
Already though, it's like,
Okay, it's only February, so we have time. If you're not happy with where I have placed you currently, you come talk to me, you talk to your parents, and we'll see if I would consider changing it. Okay? It's no judgment on you or it's just looking forward to Algebra 2 honors, Algebra 2. I hate to say it, there's no proofs, but it does get, I mean, math classes do get more challenging as we progress. So, it doesn't mean that where I placed you right now, that's where you have to go. If maybe I put you in honors and you feel like, you know what, I think I need to be in regular, then that's a conversation you can have with me. Or, if you say, I think I could really do honors, which you recommend me for regular, so come talk to me, you can email me at your convenience. Okay, so just I just need those back by next Tuesday, that's all. Okay? Okay, guys.
how can you tell if it's right? Is that equal?
If they're equal, it's right. Remember, because that's what we did just done.